So, the today the paper is as it says up there. Can I hide? I want to hide the thingy. I don't know why it's. If I press the button there, will it? Oh, I don't know. Whatever, it's fine. Um, the paper today. If I go back, can I go? There we go. The paper today is the chain of thought reasoning without prompting from Wang and Zhou, and then the corresponding code base and kind of the further explorations are at something called Entropics, which is you can just search on GitHub for Entropics. That's Entropix. And that is an implementation of uh, a similar but not entirely the same technique that we have here. So, question is, what do we have here? Is chain of thought reasoning. And yeah, so we have some theory about it. And then the paper itself also does, I believe, demonstrate, and I managed to track down a couple of repos of the um, implementations of the paper itself, as well as, so I might, if I had had more time or adequately prepared, then I might have also grabbed some of those code bases, but I just have the Entropics one to work with. So those are two like primary things. Um, for those who don't know about chain of thought, it is oftentimes the like a prompting technique. If you're working with LLMs, the phrase "let's think step by step" often comes up a lot in terms of like how to get them to increase performance, be a little more accurate. You need to give them some time to think. Essentially, is kind of the general principle. And then in our material today, um, the paper from Wang and Zhou, um, the thing that they are exploring is what if rather than prompting the LLM to start thinking, what if we can make some educated guesses about where it needs to think during the decoding step and actually just train that in rather than having to um, do any prompting specifically to get that to kick off. And then the um, paper or the repo also similar does something similar with except what they do is they measure entropy. So they're kind of looking and they're using that as sort of a proxy for uncertainty. And then based on kind of the entropy and entropy variance configurations, they will do a different kind of sampling based on what that entropy presumably indicates about where the model is in its generation process. So I have, and the big thing here is, or like the thing that sent me down the rabbit hole was, okay, uh, O1 preview is OpenAI's kind of frontier model right now. And if you work with O1 preview, you will see it thinking. And for a while, I was like, it's not that interesting. It's probably just like a multi-agent chain of thought hidden behind their API, and they're charging me like the bazillion dollars for every token. Um, but I was in looking at some of the research papers coming out of AI of OpenAI, and then discussing with a couple of friends. Um, I've sort of landed in the camp of like it's probably more sophisticated than that, and I think techniques similar to these ones are probably ones that they used, and probably my guess would be that something similar to this is probably like at least a thing that is used, and then probably some further optimizations, et cetera, et cetera. Um, let's see. Yeah, okay. We've got, I was just looking at the chat, but I see you got it, Roger. So yeah, the purpose is yeah, so it's basically I'm gonna try and cover like give a good overview of both, and then we will kind of take it from there. So what is slide next one? Okay. So the thing with the paper is what they are doing. So during decoding, um, what they do is they look at so normally when you're doing decoding for the most major LLMs these days, primarily we just do greedy decoding. Like the optimizations we make tend to be on like the training side or the data set side, or maybe some like inference optimization. We don't really tweak decoding too much, or at least that's my general experience, is that unless you're specifically going to go tweak decoding, then you don't tweak decoding. Um, but with the technique they describe in the paper, they look at during decoding the I think it's a couple of metrics, but I know it involves looking at like the logits and using that as a which is sort of like the probability of what the model is going to say next. And if it turns out that if you look at like the top K um, highest logit uh, predicted next tokens, oftentimes you'll get these kind of like diverging paths if you like follow it to the end, essentially, where it's like it will like uh, path number one is like yes, and then path number two is like yes, but, and then path number three is like uh, yes, and then we sort of continue looking for among that top K, are there any of them that are where the model is naturally following a chain of thought type response? And then if so, can we extract that and then use that to continue our decoding step rather than just greedily decoding kind of the first thing that comes there? So yeah, I guess I will. I can like pause there. Does anybody have any questions or anything like that? I want to grab the paper real quick too, if I can. Um,
Yeah, so I
but
think the biggest question for me from the paper, because I didn't get a chance to like super duper close read it this week, but it's sort of how do you um there's two questions. So one is just in general, like, okay, so you can imagine that there's different ways it could go and fill out the rest of the sentence. Like, how do you choose which one, right?
mhm,
So I think they talk about that in the paper.
they do a
And
little bit,
then
yeah.
and then more generally, it's like, yeah, but how would you use this in general if you didn't know that it was specifically a multiple choice question or a numeric response, simple kind of a situation.
Yeah, so I think that is something that's mostly covered in the uh paper at or like the kind of at least in my exploration of things, it's been that's primarily been the question, is like when do we stop greedily decoding, and then what metric do we use to indicate, to like decide what we're going to do when we stop, and then is there a difference between stopping because of metric X or stopping because of metric Y, which I think we'll probably get into a little bit. So the essentially the answer to that question is we made it up. So the ranking paths are based on a confidence metric. So I believe like the logit probability is the proxy essentially for confidence when it comes to the COT decoding in the paper. And then the in the code base, they are just doing, I think this actually isn't correct. I think we have a custom or adaptive sampler in the code base. But the COT decoding um, is ranking the reasoning paths. So presumably there's some condition that says like this is a reasoning path and this isn't. And then there's some kind of metric that is logit based for confidence. And I might have that able to jump to the to in my little paper notes, but we will see. So yes, and then yeah, originally I thought this was that they were essentially doing the same thing, but it what I sort of started to understand was that like sampling and decoding are kind of they're close to each other, but they're not the same. So the uh, we have the reliably selects COT paths based on answer confidence. The question is, how exactly do they determine relative confidence? Um, but it's not jumping out at me as to what they do. We have like, they can't reason if we only do greedy. We have COT decoding. So this is our technique reliably selects the COT paths based on confidence. But yeah, I do want to know more about exactly
Yeah,
how they
so
do that.
I think in the
Mm,
paper they give an example where it's like, how many bloody blahs does, Sally have at the end, whatever.
mhm.
And so then it'll say, you know, Sally has 23 apples or whatever. And so then they look at the last token that's some kind of digit or number or whatever, you know. And so if it requires multiple tokens, if it's like 123 is either two or three tokens or whatever, then that's fine. They combine them together. But
Y-
that occurs to me as a not terribly generalizable technique in general to just say like, oh yeah, like this will work. We'll just wait for a number to appear in the output.
Yeah, no, I agree with that if that's the case. My thought would be if what you can do is do that on something like given the answer 60, we average the probability differences for all the tokens in that answer. If there's a way to um like extrapolate from like if you can generalize that out in some way to general COT to be able to find the valid COTs, then it would be
Yeah.
more more useful. But exhibit a significantly higher delta, highlighting the model's increased confidence. Each decoding path is marked with its corresponding delta value in blue. What's table one here?
Yeah. So I think in that
Mm,
technique, what they're saying is when you say Sally has 23 apples, they're saying in particular that three that got output was way more likely than any other token, way more likely than any other digit, way
mm,
more likely than horse, blue, or any other token, right? And they're saying that that's the sign of a very good chain of thought, is that when it output the number, not the beginning of the number, but the very end of the number, it was like screamingly sure that that's how it
mm,
should finish. And that does make, in my opinion, for an interesting paper. Say, oh yeah, that's really interesting. But again, that works if you have like a single question and you know that it's a numeric answer, it's a grade school math problem, And they said like even if it doesn't answer it
mm, yeah,
properly,
right,
you
yeah.
can then like append on it something like, so to reiterate, the answer is, and then get it to output the number, and then you
Yeah, yeah.
check that probability again or something like that, right? But again, it's like, okay, how am I going to use that if I'm asking it to write the code for some whatever, whatever? You know what I mean? It's
Right.
not such a black and white thing anymore.
Yeah.
But
So
Ted,
like, yeah. Go ahead.
yeah, I was going to say, but Ted, so is the idea that it drives it to a point of high confidence, that doesn't necessarily imply it got there through chain of thought, does it?
That's basically what I thought the paper was saying is that they found a very high correlation between when it has a really high confidence on the number it's spitting out, then
Hmm.
it likely used a chain of thought. Whereas if it had a shorter answer and it just says, Sally has six apples, then that last number is not as big a difference between six and seven or some other token more.
If you there was an image in the paper, if I recall right, that kind of illustrated this really well.
Yeah, I think I have that on
You
screen.
pull
Is
that
this the
up.
image you're thinking of?
Your
One,
You're
screen
not
is
showing
pretty
your
close.
screen right now.
Oh, I'm not. Let's see. Let me see if I can switch this
We
then
still see
over
your
to
slides
that.
not in
Oh
presentation.
no. Let's see if I
Yeah, we
can I
lost
do
one of
an
the monitors, it looks
yeah, I'm curious as to okay, so if I do desktop two, does that show it to you correctly now? Like, can you see the
No,
paper here? No.
no.
What the
We
heck?
got
It
to,
hasn't
we can see your cursor,
hasn't changed the share. I don't know if you have different.
Oh, there we
There we
go.
go.
Okay,
It went
I
back.
figured it out. I figured it out. I figured it out. I know what's going on. So yeah,
All right.
when it's in that presentation mode, that's when it's overwriting. Okay, so yeah, I'm looking at the paper here, and I've got this this kind of branching paths here.
And
So
then there's the one that has the blue highlights on the based on confidence. I
That was
believe it was
earlier in the
earlier in the paper. It's like right in the first section of the paper.
That is figure, and then we have some math there, which
I
may
think
be
table
helpful.
1 is what
It's this
Sully's
guy,
talking
yeah.
about. Yeah, that guy.
This one. So we have we have greedy path, alternative top K paths, and then needs to pay $60 for 16 glasses. Every second glass only costs 60 if, and then therefore we need to multiply, and then needs to pay. Okay, so yeah, so we have the number here, which maybe is what we're looking for, considering 0.994 right there, which
Yeah, that was the thing that jumped out at me here, Roger, is that as it was flowing through, that this one token stood out amongst its peers and amongst the other K paths. So it's kind of like a two-dimensional differentiation in terms of its confidence. I'm not sure. I didn't read the rest of the paper in that level of depth, but that really stood out to me.
Yeah, so if you go back to table 1, what's not shown is where did the blue number get calculated? And
You mean
my understanding is, I don't know if you guys can tell with Warren's screen share, but there's a bolded word in each of the answers. So $60, whatever.
Then we have 64 at the bottom here.
So the second example, you can see it a little bit where the word even is bolded in K equals 3 and K equals 4. Okay. So I believe what they're saying is that the blue is how much higher the score was for the bolded word than any other, than the second best token at that same position.
Oh, so are they, because I was wondering how are you getting the probability before you actually generate the token? So is the idea that there's a positional encoding with a very high confidence that presumably will have the same number prior to generation, or is that not how that works?
No. I think basically what they're saying is something along like what I said last might have been wrong. But so if you look at like K equals 3 at the bottom example, okay, 1964, an even year, okay. What they're saying is that in the formula, it looks like they're subtracting the probability of the previous word from the current word. So they're saying even is much, much more confident than an, the word that came before it. And so what I'm just not 100% sure is exactly which words do you include? Do you include all of them? So you always compare like the first word to the second word, the second word, the third word, the fourth word, fourth word. And like Sally was saying, like you just find the largest one anywhere so that you don't have to do that trick of saying like, I will only look for a number, or I will only look for a very specific spot.
I believe they mentioned something about doing that with regards to, let's see. So they explore, I know we explore the tokens, or we explore alternative top K tokens at the first decoding step, and then you greedy decode from there.
Right.
But then my question is, when exploring those alternative top Ks, if you don't have like a leader like you do up here in kind of these GSM-8K examples, then how do you pick, like if there's multiple potential chain of thoughts in the top K tokens, how do you figure, how do you like make that educated guess of like this will be a COT, or and then be like how do you pick which COT is like an actual good one?
Yeah, no, I think what they're saying is you hard code K, so you decide in advance I'm going to do 10. Okay. So you take the top 10 probable first tokens, and for each one of those, you do greedy decoding until you get to end of sequence. You just let it run for however it's going to run. Okay. And that's where then you calculate that metric that was in blue for every one of those 10 sequences. And I'm not 100% sure how you calculate that number that's in blue. And then basically they just pick whichever one has the highest blue number.
Yeah, so I think I think you're onto that here. So upon examining the model's logics, we found that the presence of a COT path typically leads to a more confident decoding of the final answer, characterized by a significant probability disparity between the top and secondary tokens. When it says top and secondary, does it mean first and last or first and
That's what I
next?
wasn't clear. Are they talking about consecutive ones or just
The
the
top two
most
tokens at the
confident?
teeth decoding step in the kth decoding path. So the top two tokens. So it's just of all of the tokens being generated, then the top
Yeah. Okay.
two,
So
if
then
there's yeah.
that
Right.
sounds more like what I said at first, which is that word versus any other possible. So even versus any other possible token in that one spot.
Mm-hmm.
And in order for it to have a 0.9 something difference, then even itself must have been like 99% probable, you know,
Mm-hmm.
for the second best thing to be 95% lower or something.
Yeah, yeah. And it's to me what stood out was that they are the probability disparity is primarily what they're looking for, which is the
Yeah. But I don't really understand why there's this summation and one divided by answer. And
Is that just the probability of the entire sequence? It's for all x's in the answer.
X1 minus X2. I think X1 and X2 are the top two tokens at the teeth decoding step and the kth decoding path. So I have X1 and X2 and then X uh to the what less than T. And then oh so T here's the decoding path, I think. Uh math. It's hard.
yeah, so those expressions, the probability of a particular token given
Given.
all the
Yeah.
tokens that came before time t. So it's really just saying what's the probability of that token, at this point in the sentence. So you can sort of ignore the fancy math and just say it's the probability of the most likely token minus the probability of the second most likely token. But I don't
Up until
understand the
this point.
summation part.
Mhm. Up until the summation part.
So
One
yeah,
over the answer.
The
so to
stuff on
the
the right side, I think
to
you
the
said.
right of the sigma, you have the most probable minus the second most probable. That okay, fine. Like even is more probable than odd, or even is more probable than the, or whatever. Fine. But then why are you summing this
So
across?
Yep.
You,
this divide, so they're doing it for all the t's. Is that what they're doing? Xt belonging to answer. So for
That's what it looks like.
all the positions and looking at the
Right.
probability given the previous. So that's the
So they're
perplexed.
averaging it across
Yeah,
all the tokens in the answer.
So the longer
for,
the answer, the
huh.
across all the answers, or
so it looks like it's
No, I
kind of the
got it.
mean.
I got it. Yeah,
Hmm.
it's to look at how much does that one token stand out relative to the other tokens on that kth path. So it's computing the average to basically normalize it, and the normalization uses a sum as an average, and so the sum is to accomplish that average. And so the ratio, the delta K of the answer, I thought it was two. I thought it was a tuple, and I didn't really. It's the delta K of the answer is larger. It's just an observation. It's the sentence just at the top of this. It's not algorithmic per se. They're just trying to describe that the token of the chain of thought response stands out against a normalization of the confidence of the rest of the tokens in that case
Right.
unraveling.
But what's confusing me is you're not taking the probability of one token minus an average. You're actually doing an average of the minus thing, which seems to me like
So you're
that's
normalizing it also across the other answers. Or sorry, across the other tokens. So they're basically saying this one, the answer token seems to stand out amongst its peers and against its normalized against the peers.
if if I'm understanding you right, though, then for something to score a 0.94 or whatever it did, or maybe that's a different
Just sort
number
of
that they're
lifted
showing, a
from
different
another.
metric. You can't be 0.94 better than all 7 other tokens that appeared in that sentence. That would mean that every other token had to be below
I don't. I think these are
0.05.
separate. I think this is computing this delta K, which is just saying that this is bigger. I don't think this is actually the confidence.
Okay, so
But
this is maybe
Ted,
like the average confidence instead of the peak confidence that was shown in table
If you
one.
look at this sentence right before the equation, it says, interestingly, upon examining the logits, we found that it leads to a more confident decoding of the final answer. So this is like some sort of a ratio to show that delta, not to show the actual confidence.
Oh, okay. So in this case, I think answer again means that theoretical concept, like just the numbers,
Yeah,
just the word even, or
that's right.
just
That's exactly right.
23 or
That
whatever.
stands out
Yes.
relative to the other.
Okay,
That's
fine.
exactly
So if
that's
your
exactly
answer
what I
is
mean.
is 123 and it's 3 tokens, then you do have to like kind of do this across all average all three
And
of
it
them.
doesn't compute to the 0.994. These are two separate conversations. The 0.994 is up
Right.
there. This is
Yes.
the
Yes.
differentiator, the
Right.
normalization that makes that 0.994 really stand out relative to the rest of the other tokens.
All right. Thanks, Sully. So yes. So then my thing that I had originally brought up with Warren is I still am not sure how you generalize this to not needing a really super specific answer that you've grabbed out of the response.
Yes. Well, my presumption here is that the like if the pattern that we're looking for is what we are seeing when we have a 60 that we know is the correct answer. So if we can find a pattern that is like normal, 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 really high, normal, 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 then that's probably a COT, is I presume how that's being determined.
Yeah,
Um,
and so it makes sense for this kind of like math problem or whatever. But again, if I were just asking it to program the linked list blah de blah function,
Which is
like
exactly the data set that they used, right? It was like one word answer math
yeah,
word problems.
right.
yeah. And I think so their computing delta requires identifying the answer spans in a model's response, extract the last numerical value, set-based reasoning tasks. Alternatively, we can extend the output with the prompt so the answer is, then align the continuations with the spans.
Warren, you're only seeing your slides again.
Ouch. What? How did that happen? I didn't even press anything. What if I do that? And then I do this?
And you did
Put it
something.
back.
That was the first thing you did.
Okay. And then
Whenever you just did that, went away.
okay, now can you see the paper again or no?
Yeah, only the paper.
Only the paper. Okay, good.
Only
No,
it
no, no.
wasn't
We only see the slides.
the
You
Oh,
only see
paper
the
one
slides. I'm
wasn't.
sorry.
slides.
Slides. We only see
Oh,
slides. I'm sorry.
wild, 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 wild. Okay, so maybe I can't do it full screen. Can you see both the paper and the slides now?
Yes.
Okay,
Yes.
The
so
other thing
maybe
you can
we'll
do is reboot into Windows mode, and that'll probably work really well too.
yeah, if I wanted to go swap to the forbidden Windows partition, I could probably do that too.
Okay, so we
yeah,
just
but
lost.
when you do both, then the font is so small on the paper side, it's very
Yeah, I
hard to read.
know. Let me see if I can. I'm curious if I minimize this, then this should work. So if I were to minimize that and then pull this up, does that work?
No.
No.
And we just see your
This is
cursor.
this is wild.
We see your desktop, so we see what is it?
Really?
Anon exports and
Yeah,
contrast
that's
photos.
wild. Okay. And then if I do this, okay. Hmm. Let's see. I suppose I can do,
How
I
many
have,
AI developers does it take to make a window appear on
right?
a computer?
Apparently,
ChatGPT, how do
I
I
mean,
get
it's
Warren to
annoying, but
share this?
theoretically, you can make your window big without doing full screen.
in theory, yeah. Oh, okay, so I see this isn't even picking it up. That's very strange. Can I do a portion of the screen and then share this? And then I can do this, maybe?
Whoever said ChatGPT, that's too old. You need to build an agent for it to do it
Yeah, I guess
automatically.
so.
So now
Okay,
we
so if
see
I
those folders, just a tiny chunk of now a bigger chunk of the folders.
That's wild. Okay, for some reason, Zotero does not want to cooperate with Zoom today, which is very unfortunate because that is where I kept the paper. The question is, how do we work around that? Well, what we could do is we could just pull the paper up in a browser like a normal person instead of having all of my notes everywhere. So if I do
How
a new
did you read
share,
everybody's thoughts just like that? That was crazy.
We're decoding, baby. We're decoding. Okay, so let's get rid of this, and then let's do this, and we're gonna do. Give me just one moment here.
Oh, you don't even
Um,
have Brave? Jeez.
no, I don't. I am
This
just
is just
all over the
embarrassing.
place today. So if I
Yeah.
go there, and then I go chain of thought, and then I have that on
Victory,
that side, and
victory, victory,
then we're
victory.
in good shape. Okay, cool, cool, cool. So if I can go maximize, and then unfortunately I don't have my notes that are all nice and configured here, but if I move this over there, then I can see them, and then I
Maybe
will
you
be able to
can,
cross-reference.
yeah, maybe you can press that left arrow on the top left, right above abstract on the
Mm,
left, on the left above
on
abstract.
above abstract.
Yeah, that
I
left arrow.
actually,
No,
yeah,
no,
I
keep
can't.
going down to the right now. There.
Yeah, that one. There
Yeah,
you
okay.
go, slightly better, but maybe now do just control plus or command plus depending on whichever system you're on.
Yeah, yeah, yeah. I think that's the move. So I wanted to scroll down and what was I identify the answer spans was what I'm on. So if I go spans, there we go. And then we go M. Okay, so computing delta requires identifying the answer spans in a model's response. One common approach for public models is to do the thing that Ted was talking about. And then we can also extend the prompt and then align the continuations with the spans in the decoding path as the answer. And then
Wait a minute. I missed it. Did you define what an answer span is?
I did not actually.
Okay.
But let me see if I have, I don't know if they do either span. Can I do
I guess must be something I just hadn't heard before.
perhaps?
So,
Okay, so
so in
that's in the end of
general,
the paper.
answer span, it just means that what's the answer, okay? But it could be
Hmm.
more than one token, which is why it's not answer token. So if it's the number
Oh,
123 and that's three tokens,
three
then that
tokens, right? Yeah.
span is a span of three tokens,
Yeah,
okay?
yeah, yeah.
So they're just
Okay.
generalizing whether it's one or multiple tokens. But I still don't know how exactly they find that particular subset of the text, that substring. But
So, Ted, to answer that, do you think it'd work if they did either a few shot or fine tuning or something like that to essentially bracket the answer in, some sort of syntax? Between the square brackets is the answer or something
Don't
like
think that
that.
they're
yeah,
trying to solve that problem here, right? Like I think what they're trying to show is just this is like a introductory paper that's just showing here's what we discovered, and that it's an indicative of a level of thinking and analysis without prompting. So more observational versus kind of declarative, right? When I read the language throughout the paper, it's like we observe this phenomenon, we observe this
right,
phenomenon.
right. They're not
Um,
saying we've solved all problems with LLMs because
yeah,
of this.
Gotcha.
See. Yeah, and I guess to contrast a little bit, so we have I'm iffy on the confidence metric in the paper, but in the repo, the confidence metric is a lot more clear to me, which is they calculate the and perhaps I should grab the repo itself here, although I'm not sure that I'll be able to search it up in time, but we'll see if my source graph skills are good enough to be able to do that live. But what they do is they measure the entropy and the var entropy. The idea being, um, if we compute if I go here and then I go there, then I go, if I compute the entropy of the logits, the entropy of the attention, and then there is like an agreement and interaction strength score that's generated there. And then based on putting all these scores together and the log probs, so we have that, but we don't really use it. And then we're going to do this kind of sampling method. And this is kind of the interesting part to me primarily, which is we have like 4 conditions of based on where our entropy is score. So entropy score is. So we have low entropy and low var entropy, which means I believe that's like basically high confident. We are like there's not a lot of uncertainty in how we're generating here. So we are going to the logits, and then I think, so this is just the if, and then return the logits. I think it's maybe more clear in the other sampler.py. I think that was what made sense to me. Calculate metrics, and then we have sample.
Warren, going back, do you have how they calculate those individual metrics?
Calculate the
entropy, the var entropy, the attention entropy.
Yeah. So I know that the metrics attention entropy. So do we have a metrics? Let me find some references here. And then do we have temperature adjustment definitions? We have these, and then we have the metrics. So I think the metrics are calculate metrics. So calculate var entropy log soft max of the logits. So do we have, so this is just a JAX thing, I think, where you can just get an array of the logits there, or of some computation on the softmax here, I think, of the probability distribution is what it says. So essentially, to me, I think it's just like that is something you can pull out of Torch or JAX in order to get something called entropy, but I'm not exactly sure what operation. Here we go, I think. Logits axis equals axis.
Yeah. It's a softmax p log p. That's what it should be, I guess. And that's probably optimized implementation.
Yeah, so you can see entropy, it says probs times log probs. And then var entropy looks like it's the variance on those values instead of the sum of those values.
Yes. So the entropy being I am like the sampler part makes it make sense to me, basically, which is the high entropy but low var entropy. So we are highly uncertain the whole time, which means I need to stop and ask a question. So what they do here is insert a like ask clarifying question token. I believe it's clarifying question token here, which I don't know exactly how they implement that. There's just like a particular token that is probably somewhere in the tokenizer, but I looked through it and I didn't see a special token that's specifically reserved for it. But in the prompts section, they have I believe it is, an ant thinking token here, which I believe is what corresponds to not the ask a question, but the one of the other special tokens, which is the triggering the thinking section, which is kind of the like the interesting part to me of like, okay, this is kind of similar to what O1 preview does, where like some condition triggers a thinking step essentially. But I am not sure.
So, so are there 2 different kinds of injections happening? If I understood?
Yes, I believe so. Or actually, there's more than that. I'm not sure exactly. I couldn't find the other special token, but there is essentially, I don't know if it's specifically an injection for all of them, but I know there's essentially like 4 states that we're looking for, which is back down to here, which is like if these conditions, we're going to do this type of computation. If high entropy, low var entropy, so we're very uncertain, like here's a clarifying question token that we're going to jam in. If we've just asked it, then our further sampling should be with a little higher temperature, which I think is a later optimization that was made. And then increased temperature based on attention entropy. So we have like another entropy value that we're kind of using for some additional information. And then we have low entropy. So we have low uncertainty, but a high variance in the like in that uncertainty, which means there are probably multiple answers here, and I'm not sure which one is right, but it's like consistent that in the way I need to answer them is kind of how I'm reading that essentially. And then there is a let's see. I think this is a stop and think one. So high temperature. And I thought that this had a I thought that this had another special token, but I may be mistaken. But yeah, so I guess like to me, the thing with the paper, whereas they have their like the computation delta or whatever here, for their like how we are going to diverge here was like to me it was like, okay, these are kind of doing the same thing, but they're doing it at like a different step, is my kind of understanding here.
Yeah, so if I could jump in,
Yeah, go for it.
I don't know that I followed the specifics of the different branches, but philosophically, they are using a similar train of thought by saying if you look at not just like greedy decoding, what's the top token, but if you look at in general, how confident is the model as it's spitting out several tokens in a sentence? You have different possibilities. So the best case scenario, right, is you have low entropy and low variance, which means that it has one really confident token every single time. Like I'm 90% sure the next token should be this, and then the next one I'm 90% sure it should be that, and then the next one I'm 90% sure it should be that. So if that's the pattern you see, then it's something along the lines of keep decoding. You're probably on a really good track, right? And then some of the other cases are like, well, what if some of them are sure and some of them are not? Then maybe you want to like explore the, whatever. And then of course the worst case scenario is none of your tokens are sure. So if you have high entropy and you consistently have it, then that means like you want to inject some sort of additional prompting because basically the LLM was not confident about anything that it said at any point in the sentence. It's just completely, lost. So that seems to me
Yeah,
the high level gist of it.
generally speaking, yeah. And then to me it was sort of interesting that like the levers that they're pulling in response to this are yet like they have the special token, but then I thought that when it was like super high confidence answer that they would crank the temperature down while it's continuing to sample and then what they do is measure attention varientropy and then jack up the temperature and then adjust the top P of their sampling method essentially is
Yeah, so
what.
increasing the temperature will give you more variety. So if you think that so far I don't like the answers, then
Mhm.
maybe getting more variety will get you a prefix, which then all of a sudden it latches onto and says, ah, that was a really good start. Now I'm going to have some high confidence tokens coming after this.
It's kind of think out of the box.
Yeah, like think out of the box, but then once you start down that train of thought, you might be like, ah, now I found my footing and I'm high confident in my tokens. In a perfect world, that's what you'd like to see happen.
Yeah, and I think that they have their little uh, quadrants for like, okay, we have our four
Except
methods kind of thing. So.
except that increasing the temperature may lead you to the wrong path as well,
Mhm.
because even though you've reduced the entropy, but your KL divergence with the output may have increased. So you may choose something which you feel good about because of the increased temperature, but may take you the wrong path.
Yeah, but they're saying they only go that route when already the LLM is unconfident in anything it's saying. So they're like, we have nothing to lose. Let's just raise the temperature.
I think, yeah, that seems very much the vibe essentially of the whole project, where it's been just like, okay, let's throw some stuff at the wall and kind of see what happens. Turns out it's seems to be going pretty well. And then yeah, the torch is a little bit different. I remember the implementations being a little bit different. Um, but I guess I want to see if there's anything interesting in we have the um in the little presentation here. So if I do that, and then hopefully this doesn't break anything. So yeah, we have the without the systematic ranking of the decoding paths. So where my head is going is like, can I combine these things? Which may be something I try to explore this weekend a little bit. But let's see, agreement metric. Yeah, I was curious about how they generate some of these metrics where it was like there was something specifically in the repo that uses agreement as part of that computation. And then we have like a interaction strength that is used in that sampler.py, which I guess it quantifies the overall magnitude of attention, indicating how strongly the model attends to the input sections. And then the agreement is measuring the consistency of attention across the attention heads, with higher values indicating unified focus, which is interesting to me.
Yeah, see, that confuses me a little bit. I don't know if somewhere else they say sort of which layers they're looking at the attention, because you have very different attention patterns at the early layers versus the late layers.
Yeah, I think where would we have our attention stuff, I think.
There was, when you were looking at metrics, there was this attention entropy, and wasn't right there, but if we saw where the attention scores came from, we could figure out like which layer or whatever, where in the model it
Yeah,
was
yeah,
coming
yeah.
from.
I remember over in the I think it's stats might calculate it as attention stats. Yeah, 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 right. So we have number of layers, uh update, softmax, new entropy, self dot. Oh, torch stats. Is that going to make more sense? Looks like it's mostly the same.
So basically, I see them initializing var entropy. See if you can just find where they actually calculate the new one, where they overwrite that.
Let's see. Update. Well, yeah, so we have an update here, which is
Yeah.
You've got a
layer.
new
New var
var entropy
entropy,
right above
right.
above it.
So new var entropy comes from like just like 4 lines above it.
Yeah, so torch dot
Yeah,
so
and
this
so
is the
then
log props thing, I think.
probs comes from softmax scores. So the question is, where do the scores come from in this update?
I
I don't
believe,
know if we can tell that from here, or if you'll
yeah.
see who calls this function.
Calculate metrics has some of this.
Calculate
Yeah.
metrics has some of this.
Yeah, I mean, they're doing the intuitive calculation on the attention scores. It's just a question of where, who's
It's one of the
passing
first
it
ones we
in,
looked at. There,
which layer.
no,
Yeah, yeah, I think we gotta to
it was in
be.
sample.py. We had sampler.py had a calculate metrics function that did it.
Yeah, let's see. We've got simple calculate metrics. Yeah, yeah,
Yeah, so you can
Yeah.
see some attention stuff going on there.
Yep. Yeah, and so there's the attention probs. So the question is, where do the attention probs come from? Where in the model?
Attention scores.
Mhm.
Yeah.
we have
So
any
they
more
passed into
references
this
to that?
routine. Yeah, they're passed in.
They're passed in.
So you need to see who's calling calculate metrics.
Mhm.
Okay, so if we find references to that,
Ah, nice, only one.
okay. I wonder if this is, do we have more?
Is that your main sampler for?
Presumably, it says def
Yeah.
sample.
So then
Yeah, yeah.
you have to see who
Yeah.
calls sample.
Yeah, just go back up stack.
Let's see. Def sample. Oh, wait, this is the other sample, isn't it?
I don't know.
Sample. There we go. So it's who calls the sample is the
Right.
question. Score sample, maybe? Score
No,
sample
it
sample,
uses
yeah.
it.
Okay.
Up
Let me
above, I think.
Yeah, let's see, was it's defined as
Is it right in that for loop? Nope, you went past
too
where I was
far.
looking.
too far, too far.
Go to the for
Yeah, right there, 171.
sample logits. So there's this core implementation of the underscore sample that's doing it.
Yeah. Do we have an undersample routine in this class?
There it is. Oh, it's just a structure.
Looks like it.
It's just constructor.
Oh.
Uh,
Hmm. Yeah, I'm not particularly well versed in Jax either, but it's kind of the
No, I mean,
closest I
somewhere
could
there has
find.
to be a connection to the actual model. So then we would see
Hmm.
where, which attention layer, which layer it's looking at the attention from. My guess would be a late layer, but still, I'm kind of, curious.
Def attention, do we have that? Output.
And then they're
In
defining
layers model
transformer,
params.
right? And so then you're going to
Okay.
have your models can be multiple layers. The question is, which one are you pulling your attention scores from? Or are they pulling from every single attention
Attention
layer and
stats.
combining
Yeah,
them?
attention. That's what it looks like to me. Like layer weights I, and this is just like for I in range model params number of layers as far as I can see. So presumably it's like let's make these scores for every single layer and then see if
Okay.
there is some sort of like threshold maybe.
I have no specific reference I can think of that says where people have published like the variance of these attention scores follows some sort of pattern.
That is, it's not. Oh, they also have a little notebook that might make it yeah, it's this little guy here. I ran this over the weekend and ended up with params weights and then load and then KV cache, model attention stats, average entropy, standard error update, RMS norm, rotary attention. Yeah, let's see. Oh,
Maybe
model
they
params
really
in
are
current
just
position.
doing all layers.
Yeah, I think so. Uh,
That's
and then main is here's all the prompts. And then we can, what, apply scaling here? That's pre-compute. And then build the attention mask. And then we calculate it. Sample on the logits. Min p, if min p. Yeah, as far as I can tell, it's just every layer, right?
okay. So then theoretically, if you think attention is implementing some unknown algorithm, right? Then um if all of those algorithms are firing confidently, then maybe you'll have low attention variance, because
Yeah,
each
that's
piece is kind of saying like, I'm pretty sure I should be finding the noun here. And the next layer saying, I'm pretty sure I should be finding whatever the heck it is I'm supposed to be finding. And so maybe they think that if you have higher variance in your attention scores, then it's a sign that the LLM is confused.
Yeah, and then I see like in with the adaptive sample, like we score some amount of the sample. So perhaps there's just like a portion of the layers that are getting sampled and then scored would be my, and then best sample index is an array of the sample scores. And so we're basic, like to me, it's reading like, okay, we're going to try and compute this over every layer. And then we're going to sample portions of the layer and then we're going to put them
No, I
into an
don't,
array.
no, no, best sample index returns one single value, right? So,
Uh,
Oh,
I'm guessing it's more likely like
oh yeah.
substrings. So like how much of the text are you sampling over something?
Mm.
Hypothetically, you could window it, to say like at most the last 12 tokens or something, maybe. I don't know. I'm just purely speculating.
yeah,
I've
but I
been doing
think
a lot of
it's,
that.
yeah, I think it's still returning the highest value within that window.
What was the attention variance again? I don't remember how they defined that. The
We're not sure, but it might be the if you calculate the one possible definition is you calculate the entropy of the attention scores for whatever each head for each layer, whatever, and then you do the variance amongst all of those entropy scores. That's one possible.
What does that variance tell you?
It tells you, assuming that you have some attention heads that have very pointy distributions where they're
Mm,
like, I'm attending specifically to one thing and
got it.
and only that one thing, right? So
Right, that should
then
have very
the
low variance
variance will
then.
tell you, do they all look like that? Or do you have a mix of some
Hmm.
where they're really pointing at one thing and some that it's spread out, which might indicate that that algorithm, whatever that head's implementing, isn't really finding what it's looking
What,
for.
yeah, what you're looking for. Yeah. Okay.
So it's like they're all getting pointy together. It's like everybody's going downhill. It's like, we've got this, we know what's going on. And
Right.
all the attention heads get pointy because they're confident in what they're doing.
Right.
But when
So
they're not pointy, then you're screwed, right? So,
yeah, so
You're just kind
pointy
of
would
running
be
into,
assigned not to change the way you're decoding, and and
yes.
less pointy might be a sign that you want to mix things up or ask it to clarify or ask it to pause and reflect or whatever
But
the interventions they
do
have.
Yeah.
do something because you're not going the right way, you know?
Mhm.
Okay.
Yeah.
slow
Some
down.
low.
Yeah. Yeah.
Yeah. Yeah. Well,
Plan B.
exactly. Right. This is like stop and ask a question essentially
Yeah.
is that
Yeah,
that
well, do
token that's getting
something,
inserted.
whatever
Yeah.
that is, right? Yeah.
You're
Assuming
driving in fog.
2654s are, yeah. Mhm.
There you
We
go,
have
folks.
resampling in the mist. We have driving in fog, exactly, which is high on both, which is like, we're fucked, just crank it up and see what happens. Is kind of what I'm gathering out of that.
There you go. You called it.
Exactly.
I will definitely click this is not for kids on the thing
Oh
when we
shoot,
put
I
the video.
forgot, Here I am. Here I
No, we
am.
always click that. Don't worry about it.
Come out, Ted.
Excellent. Let's see. But yeah, there's and then this is actually a new edition where it's like, okay, can we throw some Monte Carlo in here and get even more
Mm.
spicy with the kinds of selections we can do, which is kind of why I was like, okay, I should try and wrap my head around this other paper so we can just put all of the papers together into one giant repo of the best model in the universe or something, hopefully. Or we will drive in a lot of fog, one of the two.
So, somebody want to explain what a Monte Carlo search, how it works, or what its features are? Is it just kind of
So
randomly guessing,
so
or?
so Monte Carlo tree search simply um, is let's say you're playing chess and you've got different moves.
Mhm.
Okay. Um, you could do a very simple, if you remember your computer science, breadth first search.
Mhm.
Okay. So you try all the 20 moves that are available to you next. And then for each of those, you try the 19, 20, whatever moves that could be your second moves. Okay. Depth first search would be you pick one of the moves and then you try its second move. And then for it, you try the third move. And then for that, you try the fourth move and so on. Right.
So just go all the way down the branch then.
Yes. Neither of those really works well for exploring chess. Right. You really don't want to search every possible next move because some of them are just crazy bad moves.
Mm-hmm.
Right. And so you want to kind of move more deeper, but at the same time, you can't just move only down one branch until it results in a win or a loss and then back your way up.
Right.
Okay. So what Monte Carlo tree search does is it says, for the first move, just pick the most promising first move. Okay. Now, what you're going to do is you have to have some way of scoring it. Okay. So Monte Carlo tree search requires that there also be some auxiliary. In the case of reinforcement learning, it would be a value function. You know what I mean?
Mm-hmm.
Right. So you score this move, and now, well, that's how you pick the best move anyway in the first place. You had to have some way of saying, okay. But so what Monte Carlo tree search says is now I had 19 other first moves, and I have, let's say, 20 possible second moves. I'm going to compare those 39 things to see of those which is the next best thing, and then I'm going to add that to my tree. Okay. And then after I've done that, let's say you went down a level. Now you have the 19 alternate first moves, the 19 alternate second moves, and 20 possible third moves. And then maybe you say of those, the best thing I have is a different first move. Okay. So basically your tree will not only go wide, it will not only go down. It'll build based in the most promising directions continuously. Okay. In the case of chess, what you would do is obviously, and whenever it's your opponent's move, instead of picking the most favorable thing for you, you'd pick the most favorable thing for your opponent as a logical move, right? You know. But so the idea is that's how you grow the tree, not just wide, not just down. And then in RL, you actually have some fancier things you do in terms of how you then update your value scoring system based on the results from your tree search. But the general gist is that it's a middle path between going wide and going deep, where you're searching in the most promising directions. And so generally speaking, with Monte Carlo tree search, you always have some sort of cost target for how long you're willing to build up this tree, because you can't strictly say build it down X many levels. You can't just say build it down 7 deep, because maybe you start by going really wide first, you know. And so typically you would say adding 100 nodes is my limit or something like that. Yeah, go ahead.
And maybe
Dev, if I missed anything.
No. I just wanted, you gave a great explanation. So I just wanted to add, maybe you can help contrast with beam search, which sounds similar, but is slightly different in how you explore. Oh, sorry, I didn't want to put you on the spot.
Actually, I think beam search is very similar.
Now that I have a good
The difference with beam search, with Monte Carlo tree search, is that the number of possible next moves that you add to the tree continually grows. Okay? With beam search, you limit the number of next things you're willing to consider. So if your beam width is 10,
right,
okay, you will add 10 nodes to the tree all at once. So I'm saying tree figuratively, 10 nodes to the tree all at once to say these are the 10 best first moves. And then I forget exactly the way the algorithm works, but then you consider the second moves from those 10, and you will, after you're done considering those, you will chop it to just 10, and you will, at every step, you will only consider expanding upon 10. Whereas in Monte Carlo tree search, you're ever considering every possible extension to the tree, whether the beginning, the end, the high, the low, the left.
I also believe Monte Carlo will pull itself back up, though, whereas I think Beam was
I think
always
so,
moving
yeah.
down.
and Monte Carlo will, so like let's say you say, "Oh, I bet this is a great move because I'm going to put the opponent in check." And then you find out in the next step you lose your queen.
Exactly.
You're never going to actually expand that path because it has such a lousy value, but you have not physically pruned it from the possibilities. You're still expending some cost sorting and saying what is the next best thing to expand. In a beam search, you physically prune stuff so that it's impossible for you to ever uh and so like let's just say you're very close to losing the game. It might turn out that that move that costs you the queen ends up being the least worst, the least bad move you have because every other move causes checkmate. Okay, right? And so that's where like Monte Carlo tree search would say like, yeah, I'm still going to keep that around, and if somehow it manages to ever make it to the top, I'll expand upon it. Um, and so hypothetically, there could be this crazy chess game where it's a queen sacrifice and then you win the game in 3 moves, right? Beam search might never see that because it just killed it off early on.
Yeah, thank you, Ted. Yeah, you did great again. Just wanted to get that out because those are two similar algorithms, but they have a difference in how much you retain in terms of uh, the current best, which is
Yeah.
kind of somewhat greedy best, versus Monte Carlo, you could hypothetically say is keeps on expanding.
Yeah, and you could imagine that for like LLM completions, you might be a little optimistic that good prefixes tend to lead to good full sentences.
Yeah.
Whereas in chess, you may not have that optimism. It may be a very confusing move that seems not so great at first. I lost a pawn, but aha, 8 levels down, great things happen. So
Yeah,
so
which is why.
you can see why in chess you would be more likely to invent Monte Carlo tree search than just to do a simple beam search.
And
Cool.
which I kind of like in this, or which is like MCTS seems pretty interesting here in that like since we're already calculating these sort of like 4 set conditions, then we can we might end up with like a more interesting tree that we actually want to Monte Carlo down instead of just beaming. If what we're doing is uh kind of looking for the best uncertainty conditions rather than the next most likely token. Because I know there's a few models, or maybe it's just utilities or something. I've seen beam search while I was generating tokens a couple of times. I don't remember exactly where, but um, I very rarely see Monte Carlo when I'm working with
No, I've
ILMs.
never seen that. But also, even though beam search has strong theoretical foundations and relatively low cost, because you can set your beam width, right? You can set your beam width to 3, and so you're really not keeping around that many options, as you go. Because LLMs are so big, the good ones, even just doing multiple 3 different inferences going, multiple tokens ahead can actually be pretty expensive. And so I don't follow this closely, but I haven't even seen people doing beam search hardly at all. Maybe in
It's
a
very
research
uncommon. I
paper,
remember that. Yeah.
yeah, in a research paper they might consider it for some small scenario, but you're not going to find people doing it in production just because it's too expensive. And remember, you're doing beam search after every token, right? So consider 3 wide, 10 tokens deep, and I pick the next token. And now I got to go 3 wide, 10 tokens deep again to pick the next token. You're doing this every single bleeping token. So
Yeah. Yeah. That and the other kind of thing that is like interesting to me that I might even have a slide on if I actually paid attention is the essentially like both of the things, and I think probably the thing that I originally was kind of looking for was the like with O1 preview, like it's doing something, and what that thing is being able to dump extra compute into inference time. So if um, and like to like one of the things that occurs to me about both of these techniques is that they're ways to spend extra compute if you have it during inference rather than just relying on training the model. Which there's any number of ways to do it, but I thought these were some interesting ways.
Yeah, that's a great point. Everybody agrees they're dumping more compute in O1. We just don't know what techniques.
Exactly. Yeah, that's my thought. It's like, okay, well, let's go through the good ways to dump your compute and then see if we can figure it out. Do I have any? I don't think that I have any particular interesting stuff in my slide deck after that. I think we've mostly covered it. So I guess do you guys want to walk through the rest of the paper or pick apart the code base some more, I guess?
We
Anyway.
are, we're at time. We're
Oh, are
coming
we?
up on,
Perfect. Perfect.
this is
Yeah.
probably do you want to, is there more to do? I mean, should we split this to 2 weeks? I mean, that is not uncommon, right?
Well, what I would say is Entropics is kind of just hitting the like the AI influencer zeitgeist. So I would expect that there will probably be some significant updates to it over the next week. Which if it's interesting, I can try, and of course I have my 16 other papers that I found that I have to try and do
Of
something useful
course.
with. So potentially there is more interesting stuff that will be around next week. That being said, if I would be happy to defer to someone else that has something that they'd like to go over, largely because I'm sure it will take me probably longer than a week to actually understand what code is being added to the repo, because I'm not really all that far down the understanding the code in the repo right now. So yeah, I'm open to either or essentially.
Suggestions, folks?
I had a question. The repo that we're looking at, what's the relationship? Is that from the authors of the paper, Chain of Thought paper?
No,
Or is,
actually, it's
okay,
entirely
so,
coincidence, basically.
okay, that's what I thought. Okay.
Mhm.
And is
It
there a paper associated with the repo?
There currently is not actually. We
Okay.
have yeah, I think they've been mostly focused on kind of implementing. I presume that it probably will have one, but there's a few more related papers that might be relevant. I'll have to go through my notes again, but yeah, I presume there will probably be a paper about this at some point or another. So once it comes up, I'll be happy to dig around on that too.
Yeah, that'd be interesting because it seems like they're exploring a lot of really cool ideas, but I'm just
Hmm.
wondering what the results look like.
Well, at least in terms of subjective results, they have been very interesting. Like I posted in the general of the Slack, the um, a question that was stumping uh, a lot of like larger models, or like semi-large models. It's like which is the question posed to the model is which number is larger, 9.9 or 9.11? Um, and the if you throw that at like a 3B or a 7B, oftentimes it'll like get it wrong or like not make sense. But using this technique with a 1B actually has it consistently getting that question
Oh,
correct, which is
oh,
quite exciting to me, because I want to see my sort of project with this repo is kind of as it evolves. I want to see it like how far we can push it. Like
hmm.
basically whatever, over the weekend, whatever compute I can grab. Okay, let's grab a 7B and see what else we got and see if we can give old Sammy boy a run for his money with a 7B or something. That's the ambition, right? So we'll see. We'll see how far we get.
And also something in here that I hadn't seen before is this ask clarifying question, that token. That sounds
Yeah,
really cool too.
uh-huh. I'm interested just to see like how that specifically is implemented because I couldn't
Right, right.
find I think the symbol only like shows up once. Clarifying. I wonder if I can. Oh, it's in there somewhere. I
Yeah,
thought I was
I
good at
saw it
source.
earlier too.
Yeah, I thought I was good at Sourcegraph, but I maybe mistaken. I believe it's in sampler, I believe.
You went through it because I saw it when you were going through the
Yeah,
code.
yeah.
Attention scores.
No, it was one. It was just when it was doing this, doing this,
Yeah,
doing this, and it was
this
trying to
thing.
figure out. Yeah, there it is.
Clarifying question token. Can I
Yeah,
find?
but that's
Well, it'd be really interesting to see how that works. So
Yeah.
that this whole idea of kind of looking at the confidence and changing the model to say, rather than just always produce an answer, but instead look at how confident it is and being able to ask more questions. I think that's a really cool thread to follow.
and that
Yeah.
implies that the interface would let you set those values probably too.
Yeah, I know they have a front end that they're working on as well. I think it's somewhere because like it would seem to me that these are, oh yeah, I think it's a specific number of token. It's like which model was I asking? I was asking, let me see if I can find it real quick. Which may be, where is it? Think tokens. Wow. It's
It's
2.6 something, yes, I believe,
yeah.
the token specifically, but I'm not sure how they like actually implemented that. I would be quite interested to.
Well, and it'd also be interesting to see if that's guided by here, here's the couple answers that I'm considering, and I can't decide between the two, and ask a question that differentiates between the two versus just something that says, I need more information. I'm not getting anywhere. I need more information.
Yeah, I was gonna assume that it would be in the special token stick, right? That was my thought. And then I remember in I think it is Torch. But let me just check through this. Reserved special.
I think the specific value doesn't matter much. It's what do they do with it that
Yeah,
matters.
yeah, exactly. Um, yeah, I know it's I know um I know what ends up happening in the model when you run it is it will that trigger will it'll this is the token essentially, as far as my uh read of it goes. I just don't know how to track this down. Because it just seems like it's just prompt here, so you would have to be importing prompts or like a create prompt template or something. And see if it's anywhere else. But yeah, this is not.
I would like to see that as just a confidence output, just everything it says, just, how confident are you? How pointy are your attention heads? Just some measure of, how downhill it feels when it talks. Instead of just having a threshold where it would just ask clarifying questions, just show me always how confident.
In fact, somebody did do that actually. I forget who it was. But let me. I don't know, I might have it handy here in one of these discords or something. But somebody basically just it was like a really simple uh HTML, just kind of like let's color the words kind of thing based on their it was like red is entropy, green is var entropy, and then 2 degree, and then let's color it accordingly.
Mm-hmm.
I think somebody
Great.
did that. Not sure if I can track it down exactly, but was it this thing? No, perhaps not. I could have swore it was from oh right. It was yeah. I think it was yeah. There we go. I found it. Let me grab this, and we go to the Oracle of Delphi, aka Twitter. Um, yeah. So second and third candidates for tokens above a certain entropy threshold, top P would make more sense. And then we have, according to DPT2, was known for making great iced tea. And then we have a little notebook to visualize the entropy too, which I can like drop off in the Slack if anybody wants to play with it.
I'm trying to catch up here.
Oh yeah, we go fast these days. Let's see. Input, get the tokens and scores, convert them to probabilities, calculate the entropy, and then generate some HTML with colored tokens.
All right. On GitHub.
So I think this is just entropy. I don't think there's a var entropy here, right?
I'm surprised it's not standard, you know, that it just would be a normal thing.
There's I know Gemini did it at one point where it would, as you, it was, and I think it was a fairly naive implementation where as it talked, it would highlight based on log props. It would highlight red or
Right.
green, and then you could click that like search with Google to check it, and it would do a little Google search to check the whatever phrases were red. I think it was. But I wish they would do it more often. It would be very helpful.
Yeah. Yeah, I think people would find that very intuitive.
Mhm. See, well, I will go ahead and cut my little streamy thing, but I want to see how
Okay.
how'd we do?